come in. Come in. Please sit down. Thank you. Sit down. Please sit down. What happened, beta?
So actually what happened, I was last week I was in the camp and I was coming down the stairs. Suddenly I slipped down and my head collided with the wall.
Just relax and let me have a look. Excellent. Very good. Look at me. All right. Good. Hurts you anywhere?
Yeah, here.
All right, don't worry. Good. I think clinical examination is fine, but let's get an MRI done.
She's in a serious problem?
No, I don't think there's a serious problem, but we should get an MRI done to actually see what's happening inside. It'll reassure me and reassure you as well.
This is the MRI, or magnetic resonance imaging machine. It is an advanced diagnostic technique.
Reshma, good news for you, your scan is absolutely normal. So relax and go back to school, okay?
Giving a better view, it yields this snapshot of Reshma's 14 years old brain. At birth, Reshma's brain was a quarter of its present size.
Brain is made up of billions of neurons, and these neurons are connected to each other through synaptic junctions.
I think brain fascinates everybody from a child to an adult, because ultimately we are what we are because of our brain. So as a child, I think it is fascinating for a child to know how we move our hands, how we are able to think, what brings us joy, what brings us sorrows, and how a single organ is able to perform all these tasks and control what we are. The parts of the brain that relate to what happens outside, then the parts of the brain that coordinate all the information that is received, and then the information is processed. So it's like an information processing system, it's like a computer, and then the output is generated.
Reshma's brain will remain more or less as such even when she becomes mother or even grandmother. Throughout your life, wonders of the world unfold through your senses, enabling you to discover and understand what is happening both inside and outside your bodies.
My versatile eyes tell me the color and beauty of a butterfly's wings. About 2/3 of the information and knowledge in the brain comes in through the eyes. My remarkable ears enable me to enjoy sound and music, distinguish between sound and noise. A part of my ear helps my brain control and balance my body when I'm skipping. So, my ear houses not one sense but two. my super sensitive nose brings the smell of the pleasing scent from a rose flower or incense stick. Taste is the sister sense of smell, and my tongue enables me to taste multitude of flavors in this fruit or cookie. Believe it or not, our sense of taste is about 75% smell. So, we experience in the brain at the same time when we sense the odors of the foods and drinks. And finally, this is my versatile sense of touch, which is not one sense, but many senses of discrete feelings.
The prick of a thorn activates thousands of nerve endings. These nerve endings join together to make up a sensory nerve. This triggers an electrical signal that lasts for about 1 millisecond. It conducts messages through the spinal cord. The impulse ascends up the spinal cord to the thalamus, a relay station. After some modification in the thalamus, the impulse reaches to the sensory cortex of the cerebrum. Here, the impulse is integrated.
Ouch!
What is the difference between looking and seeing?
All of you, look into the microscope and observe. You have to draw what you observe. And when you are observing and drawing, see that there is a very little difference, a very subtle difference between what you look and what you see.
Looking is what my eye sends images to the retina, and seeing is what meaning my brain assigns to this image, based upon my prior knowledge.
Precisely for the same reason, these masterworks of art evoke different meaning and feeling. Now you can appreciate the difference between listening and hearing. Listening helps everyone, blind or sighted. We tend to take our sense granted until something goes wrong. How would our life be different if we did not have one or more of our senses?
When a person loses one sensory organ and the other organs are intact, then the organ which is deficient, जिसकी deficiency है, that sense की जो limitation है या जो ये है, that has to be compensated by making optimum use of the additional senses which are intact. For instance, if you cannot see, then one has to depend on the other. His hearing power is more powerful, his listening power is more powerful, his speaking is powerful, his tactual power is particularly more powerful, because with his fingertips he reads the Braille system. See, Helen Keller was not only blind, fortunately her fingertips and everything was intact, but since she could not see, she could not develop the sign language because she could not see. She used to put her fingers on the lip. E,
we learn how to read and write. My heart, it pumps the blood through the body.
Brain communicates with rest of body through the spinal cord. Some sensory nerves from muscles, for example, those beginning in the arm, lead to the spinal cord in the backbone. And there are nerves that carry messages from the spinal cord to muscles. These nerves are called motor nerves. At the turn of 20th century, Spanish anatomist Santiago Ramón y Cajal was the first person to see the nerve cells located near the surface of brain. And Italian physician Camillo Golgi was the first person who put forth the theory that there are two types of nerve cells, sensory and motor nerve cells. For this brilliant work, they were awarded 1906 Nobel Prize in Physiology or Medicine. How do we know that different body functions are controlled by different parts of the brain? This puzzle was resolved by a Canadian brain surgeon. He was Wilder Penfield. In 1928, after completing education, Penfield moved to Montreal as the city's first neurosurgeon. 6 years later, in 1934, he established the great world-famous Montreal Neurological Institute. In some cases, patients undergoing brain surgery for the scalp and skull incision may have only local anesthetics, so they can stay awake on the operating table. By inserting extremely fine, low-current electric probes into the exposed brain, neurosurgeons can stimulate specific regions. For example, a mild shock is delivered to a point into the left motor cortex. In response, the patient's right foot responded. Touch another point adjacent to it. Watch what happens this time. It produces a similar response in the patient's right leg. Let us change the side. This time stimulating on the right motor cortex. Now, the left leg moves, stimulating other locations on the cortical surface, elicit a movement in the hand. Likewise, to a shock delivered to this point into the left motor cortex. The patient's right arm responded. This is another point down in the motor cortex. Here, a mild shock delivered would make the eye open. If it is left motor cortex, then the right eye opens. For one patient, Penfield triggered a familiar song that sounded so clear. The patient thought it was being played in the operating room. Still, other locations on the may elicit a vivid, forgotten childhood memory of roller coaster returned, or a fragment of a long forgotten time.
Each part of the brain has a specific location in different regions of the brain. The motor system controls the whole movement of the body. Now, for each of your body part, there is representation in the brain. For example, this is the area, this whole area is where the motor system is represented in the brain. This part of the brain responds to another part of the brain which is adjacent to it, and that is the sensory region. See, this is the adjacent sensory cortex. Now, both sensory cortex and the motor cortex have to function together, coordinated. So, the sensory cortex gets information from sensory part of the body. That means all the touch, pain, pressure, which you feel all over your body. And those senses go into this area of the brain, and that particular part of the brain gives an order or a command or functions together.
This is real human brain, but preserved in the chemical called formalin. This part is the front of the human brain, and this is the hind part of it. And this wrinkled, soft and little wet upper part of the brain is the cerebrum. When alive, it is where thinking takes place. If we cut the brain along the midline and make into two halves, one on one side and other on another side, then we get what is called a sagittal section of the brain. And so, this is the right hemisphere only. This part of the brain is the cerebrum. Voluntary actions such as singing, or writing, or drawing, or taking data, or thinking are the responsibility of our cerebrum. This part of the brain is called the cerebellum, which means literally little cerebrum. It is also divided into two halves like cerebrum. You can see how there are two cerebellar hemispheres. So every action requires a huge feat of concentration and conscious coordination. Same is true if you are riding a bicycle, or catching a cricket ball, or dribbling a hockey ball, or trying to basket a ball. If you are swinging, or if you are doing a difficult step in dancing. This is brain stem. From this part, called medulla oblongata, and to it go the nerves that control heartbeat, breathing, sneezing, coughing, and so on. This is very important too for your basic life support system. It also regulates when you sleep and awake. Imagine what it would be like if important functions like breathing, heartbeat, or maintenance of body temperature always had to be consciously controlled. These actions take a still shorter route for response. Ouch! What is called reflex. This occurs rapidly, almost immediately and automatically. Let us see how a reflex response works. As soon as this hot halwa or khichdi contacts the hand, pain receptors sends signals to the spinal cord. In turn, the spinal cord sends a signal back to the arm bicep muscles to jerk the finger away. If we didn't have such protective withdrawal reflexes, we will face serious injuries.
The will to excel has also played a very important role. Today we realize that the more we use the brain, the better that part of the brain becomes. So it is like a well-oiled machine. The more we use that machine and we maintain it, the better and better that machine becomes. So the brain fundamentally works on that simple principle, use it or lose it. The more we use, the better it gets. So similarly in sport, the more we train, the better we get.
Every thought or idea, every memory or emotion, every fear or anger, every sadness or sorrow, every joy or happiness, every love or disgust, every surprise or curiosity happens in our brain. Every time we sense, while our body receives information, our brain figures it out. So, it is our brain that keeps all the parts of our body working together. And it is our brain that determines the way we behave.
So, it is responsible for our dreams and hopes, our joys and sorrows, our pleasures and pains, our laughters and tears, our anxieties and fears, our inspirations and ambitions, and even what we think as our own sense of self, sense of being.